Resolvins are specialized proresolving mediators, SPMs, derived from omega-3 fatty acids, primarily eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA, as well as docosapentaenoic acid, DPA, and clupanodonic acid. As autacoids similar to hormones acting on local tissues, resolvins are under preliminary research for their involvement in promoting restoration of normal cellular function following the inflammation that occurs after tissue injury. Resolvins belong to a class of polyunsaturated fatty acid, PUFA, metabolites termed specialized proresolving mediators, SPMs. Resolvins, RVs, fall into several subclasses based on the straight-chain PUFA from which they are formed and/or a unique aspect of their structure. The Resolvin Ds, RVDs, are metabolites of the 22-carbon PUFA, DHA, i.e. 4Z, 7Z, 10Z, 13Z, 16Z, 19Z, docosahexaenoic acid. The Resolvin ES, RVES, are metabolites of the 20-carbon PUFA, EPA, i.e. 5Z, 8Z, 11Z, 14Z, 17Z, 5, 8, 11, 14, 17 eicosapentaenoic acid. The Resolvin DN6-DPA, RVDSN6-DPA, are metabolites of the DPA isomer, OS bond acid, i.e. 4Z, 7Z, 10Z, 13Z, 16Z docosapentaenoic acid. The Resolvin DN3-DPA, RVDN3-DPA, are metabolites of the DPA isomer, clupanodonic acid, i.e. 7Z, 10Z, 13Z, 16Z, 19Z. Docosapentaenoic acid, and the Resolvin TS, RVTS, are metabolites of clupanodonic acid that, in contrast to RVDSN3-DPA, all of which possesses 17S-hydroxyl residue, possesses 17R-hydroxyl residue. Certain isomers of RVDS are termed aspirin-triggered Resolvin Ds, RVDs, because their synthesis is initiated by a drug-modified CAX2 enzyme to form 17R-hydroxyl rather than 17S-hydroxyl residue of the Reeves, however, and as yet unidentified cytochrome P450 enzymes may also form this 17R-hydroxy intermediate and thereby contribute to the production of ACT-RVEs. All of the cited resolvins except the RVDSN6-DPAs are metabolites of omega-3 fatty acids. The following oxygenase enzymes may be responsible for metabolizing PUFA to resolvins: 15-lipoxygenase 1, i.e. alox-15, possibly 15-lipoxygenase 2, i.e. alox-15B, 5-lipoxygenase, i.e. alox-5, cyclooxygenase 2, i.e. COX-2, and certain cytochrome P450 monooxygenases. RVDs are polyhydroxyl metabolites of DHA. To date, 6 RVDs, which vary in the number, position, and chirality of their hydroxyl residues as well as the position and cis-trans isomerism of their 6 double bonds, have been described. These are RVD1, 7S8R17S trihydroxy DHA, RVD2, 7S16R17S trihydroxy DHA, RVD3, 4S7R17S trihydroxy DHA, RVD4, 4S5, 17S trihydroxy DHA, chirality at position 5 not yet determined, RVD5, 7S17S dihydroxy DHA, and RVD6, 4S17S dihydroxy DHA. The structures of these RVDs are further defined at specialized proresolving mediators #DHA-derived resolvins. These metabolites are formed by a wide range of cells and tissues by the initial metabolism of DHA to 7S-hydroperoxy DHA and 4S-hydroperoxy DHA by a 15-lipoxygenase, either ALOX15 or possibly ALOX15B, followed by the further metabolism of the two intermediates by ALOX5 to their 17-hydroperoxy derivatives. These dehydroperoxy products are further altered to the cited RVDs by these oxygenases or by non-enzymatic reactions and the conversion of their peroxy residues ubiquitous cellular. Peroxidases. RVESRD or trihydroxyl metabolites of EPA. To date, 4 RVES have been described: RVE1, 5S12R18R trihydroxy EPA, 18SRVE1, 5S12R18S trihydroxy EPA, RVE2, 5S18R dihydroxy EPA, and RVE3, 17R18R/S dihydroxy EPA. Structures of the RVES are further defined at specialized proresolving mediators #EPA-derived resolvins. Resolvin ES are formed in manner similar to what Resolvin TS COX-2 modified in activity by aspirin or atorvastatin or, alternatively, a microbial or possibly mammalian cytochrome P450 monoxygenase metabolizes EPA to its 18R hydroperoxy derivative. This intermediate is then further metabolized by ALOX5 to a 5,6 epoxide, which is hydrolyzed enzymatically or non-enzymatically to RVE1 and 18S-RVE1 or reduced to RVE2. Alternatively, the 18R hydroperoxide is converted to the 17R18S vicinal diol. Product, RVE3. Human platelets pretreated with aspirin or atorvastatin metabolize the omega-3 DP8, clupanodonic acid, DPN3, by aspirin-treated or atorvastatin-treated COX-2 to a 13S hydroperoxy intermediate. Aspirin and atorvastatin change the activity of COX-2 from a cyclooxygenase to an hydroxyperoxidase-forming enzyme. The intermediate is then passed to nearby human neutrophils, which metabolize it, probably by ALOX5 enzyme activity, to 4-polyhydroxyl metabolites, RVT1, 7,13R20 trihydroxy DPN3, RVT2, 7,8,13R trihydroxy DPN3, RVT3, 7,12,13R trihydroxy 8Z10E14E16Z19Z DPN3, and RVT4, 7,13R dihydroxy DPN3. Subsequent studies found that these 4 RVTs are also formed by mixtures of human neutrophils and vascular endothelium cells and, additionally, are detected in the infected tissues of rodents and humans. Following tissue injury, the inflammatory response is a protective process to promote restoration of the tissue to homeostasis. Resolution of inflammation involves various specialized lipid mediators, including resolvins. Resolvins are under laboratory research for their potential to act through G-protein coupled receptors, GPRs1, RVD1, and at RVD1 act through the formyl peptide receptor 2, which is also activated by certain lipoxins and is therefore often termed the 8LX/FPR2 receptor, 2, RVD1, at RVD1, RVD3, at RVD3, and RVD5 act through the GPR32 receptor, which is now also termed the RVD1 receptor, 3. RVD2 acts through the GPR18 receptor, also now termed the RVD2 receptor, and 4. RVE1 and the 18S analog of RVE1 are full activators, while RVE2 is a partial activator of the CMKLR1 receptor. All of these receptors activate their parent cells through standard GPR mobilized pathways. RVE1, 18S, RVE1, and RVE2 inhibit the leukotriene B4 receptor 1, which is the receptor for inflammation-promoting PUFA metabolites such as LTB4 and the R stereoisomer of 12-HEAT, by inhibiting the action of these pro-inflammatory mediators. Resolvin metabolites of EPA, DHA, and DPA and the myrisin and protectin D1 metabolites of DHA are under basic research for their potential influences on inflammation. One human study reported no increase in urine or plasma resolvin content after consumption of fish oil compared to a non-omega-3 oil, either before or after challenge with bacterial lipopolysaccharide known to induce an inflammatory reaction. Preliminary studies in people with cancer, kidney disease, or cystic fibrosis while receiving dietary PUFA or fish oil supplements indicated improvement of inflammation biomarkers, possibly resulting from resolvins. References